Welcome back, everyone. In today's video, we are solving the full IB Math AI HL paper 2, time zone 3, step by step, with complete explanations and GDC methods. Let's get started. Before we begin, remember that in IB Math, method marks matter a lot. So always show clear working explanations and supporting steps, especially when using the GDC. Question 1. Kailash manufactures drink container in the shape of a cuboid. The container has a square top and a square base of length L centimeter. We can see the square base. Its height D centimeter is 3 times the length of the base. So height is 3 times the length of the base. Some key information. Part A, write down an expression for D in terms of L. So it's written right over there. D is 3L. Height 3 times the length of the base. The container can hold 375 centimeter cube of drink. This means the volume of the drink is given. And this is a prism. And we need, they're saying part B, find the value of L and D. So you are given a formula for the prism's volume. So you can check that in the formula booklet. I'm solving my solutions here since this paper is supposed to be done on the answer booklet provided by the IB. Okay, so volume of a prism is given as the cross-sectional area times the length. So we just put 375 over here. The cross-sectional area is going to be L squared and multiply by D. Okay, so we know that D is a 3L, so this is going to be 3L cube and 375. And if I divided it, this is going to be 125, right? L cube. So L is going to be, if I cube root this thing, 5. So L is 5 centimeter. And since D is 3L, so D is going to be 15 centimeter. There we go. Okay, part C. Calculate the total external surface area of the container. So how do we do the total external surface area? There are LD, 4 rectangular faces of LD, these vertical tops, and the top surface and the bottom surface is a square, so L square, double of that. So let's feed in the values which are given, like 5 times 15 and plus 2 times, this is going to be 25, right? So let's quickly use the calculator for this one. So 5 times 15, and we can times it with 4. Let's do times 4 and plus a 50, because that's just a 50 given, right? So it's going to be 350 and centimeters square, since this is the surface area. Let's move on to the next part. Okay. Question 1 continued. To reduce environmental impact, Kailash is trying to minimize the amount of material needed for the production of the 375 centimeter cube container. He is willing to change the shape of the container with the radius r and height h as shown below. So now the volume remains the same, but the shape is now a cylinder. The cylindrical container of the drink must also hold 375 centimeter cube. Find an expression for the height h of the container in terms of r. So we know that the volume is given, and the cylinder's volume is also given on the formula booklet in case you have forgotten it, by r squared h. So h is going to be 375 over a pi r squared. So this is part D. Okay, we are done with this part. Let the total external surface area be A. Show that A is this. Okay, let me just solve it over here. Total external surface area. So there are 2 flat surfaces which are circles. That's why there's a 2 pi r square. 2 pi r square. And you should know this as well, given in the formula booklet. The curved surface area of a cylinder is a 2 pi r h. Since the expression given is free of h, so you can sub in your part D answer. So let's plug it in. This is going to be 375 over a pi r squared, and area 2 pi r squared plus pi cancels the pi, r cancels the r. 375 double will be a 750. and divide r and plus a 2 pi r square. Here we go. That is the answer for part E shown. Okay, part F. We need to differentiate this expression. So how do we differentiate it? A good way to rewrite your expression first. So 2 pi r squared plus 750 and r to the power -1. So if I differentiate it, dA over dr, that's going to be 4 pi r plus, this is going to be a 750 and a -1 r minus 2, right? Which I can obviously write like this minus 750 over r squared. It doesn't matter. You can leave your answer as a negative index, but I usually write it as a positive index, right? Hence or otherwise, let's move on. They're saying find the value of r that will minimize a. So in order to, this is now the calculus stationary value question. So how do you solve these stationary value questions? Let's do G1 over here. So you put your first derivative equals to a 0. Now, this can be solved using the graphing display calculator as well, or like if you want to solve it straight away, I would encourage you all to solve it using GDC, but I mean, there is a way in which we can just solve it without GDC. Just let's go, it's going to be 750 and over, that's going to be a 4 shift pi. Okay, so now I need to cube root this thing, right? So 3 shift cube root, that's gonna be, let's plug in the answer. Okay, so this is 3.90796. 3.90796, 3.90796, which can approximately be given as 3.91, right? So they're saying find a value of r which will minimize the area. So this is the value of r. Another way of solving this thing, I'm just showing you, like, what if you would have plugged it in your graph? So it could have been this way, like 4 pi, uh, I need to put x and minus 750 and fraction, and this would have been x squared. In place of r, obviously I'm writing y in terms of x. So let's go, and I can set the V window, just zoom auto, and let's see if I find the root of this equation, right? So G solve, just get the root. Okay, so you can see, like, you can check the root since the solution of this equation is my stationary value. So another way of solving this thing would have been this way, right? Okay, so hence determine whether, okay, oh, sorry, I had to do G2. Find the minimum value of A needed for the cylinder. So how do you get the minimum value? So you have the area expression already, second part. I can just sub in this 2 pi, this 3.90796 and square and plus 750 over a 3.90796. I know this will take some time, but let's just get it. Okay. 2 and shift pi, and let's feed in this value like a 3.90796 and bracket close and square it plus a 750, put a fraction and over the same thing. Let me just put it in the bracket. So 3.90796. Okay. So make sure you keep an eye on, like, what are you feeding in. So this is going to be, let's execute. That's 287.874. 287.874, which will be 288, approximately 3 sig figure centimeter cube. So that is like the application of stationary value. And now we need to find the double derivative. So you will pick your first expression. Let's do h1 over here. I'm sorry, I'm just solving everything here. But if you focus, you can just keep an eye on, like, I'm writing h1, g1, g2. So just keep an eye like which part is solved where. So double derivative is simple. It's just redifferentiating the expression for the first derivative. Okay, so that can be written as negative 750 r minus 2. So I can just do 4 pi, because r's derivative with respect to r, it will be 1, minus 750, which will become obviously a minus 2 r minus 3. And now I can do 4 pi plus, this will be a 1500 over r cube, right? Okay, so that's my double derivative expression. I'm running out of space. Hence, determine whether the graph of A is concave up or concave down for r greater than 0. Justify your answer. So now keep in mind, like, if I sub in, okay, next part is a different question. I've got my r value, so I'm just showing you this thing. Okay, guys, so I'm going to do H2 over here. I'm sorry about the space. Okay, H2. You will sub in your value of R inside the double derivative expression plus 1500 over this thing 3.90796. And I know for sure, if you look at this expression, that this value is positive. So if the double derivative's value is positive, your graph is always concave up. So this is concave up. So in your exam, you will be justifying just like this, the way I did. Sub in the value, prove that your double derivative's value is greater than 0, or the other way around. If it's less than 0, then it's a concave down. Question 2, it's a 15-mark question. On a particular day, the height of the tide h in meters at Albion Harbor can be modeled by the function this. And this is a sinusoidal function where b is a real number and t is within 0 to 24. And t represents the number of hours after midnight. So we can check the domain as well. It's given 0 to 24. And there are two oscillations given. And the cos looks the other way around. Reason being, if you know your function transformations, there's a negative sign outside. Otherwise, my cos looks the other way around. Like it starts here somewhere and goes the other way around, right? Okay, so let's do part A. Show that the value of B is 30. Okay, so we know, let's do it over here. We know the period formula is 360 divide B. And I could have done 2 pi divide b, but the question doesn't specifically says that use radian. So maybe I can use degrees, right? Okay, so this should be equal to. Now look at your x-axis. So it seems like it's completing one oscillation in 12 hours, right? So 12 hours is its period. So 360 divide 12 is going to be b, and this implies that b is going to be 30, shown, right? Okay, so find the height of the tide when t equals to 5. So we know that h of 5 is required over here, part B. And you can just put minus 2.5 cos. And this will be 30 now. And 30 times a 5 is 150. And plus a 4.5. So let's just sub this minus 2.5. Let's do 2.5. And cos, this will be 150. And plus a 4.5. Okay, here we go. And I can get a decimal answer, 6.6651, 6.6651, which can be written as a 6.67. And since this is in meters, I can write m over here. Right. Okay. Part C, write down the amplitude of h and the equation of the principal axis. All right, so if you know your sinusoidal functions, you should know that this is the amplitude, 2.5, the coefficient of the cos or the sine function. So h is, and remember, amplitude is a positive number. That negative is just a transformation, like it's a reflection, the upside down thing. right? So this is it. And we need the equation of and this over here is your principal axis, but we are required to give the equation. So the midline or the principal axis is here somewhere, and its equation is like y equals to something since it's a horizontal. But remember that your y is h. So you will write h of t equals to 4.5. So I think the context of the question says that your height is against time. So don't write y equals to 4.5. Instead, write h equals to 4.5, right? Okay, so that's done as well. Let's move on to the next part. They're saying boats can only leave or return to Albion Harbor when the height of the tide is greater than 2.65. Okay, when the height of the tide is greater than 600. So this is some key information. Okay, Robin knows that due to the local weather conditions, there could be possible errors, okay, in the height of the tide H predicted by the model. The actual height may vary by up to 10 centimeter, okay, above and below the value of H. So Robin wants to leave the harbor to go fishing as soon as possible after the time is 12. Okay, so that's one condition. Uh, all right. So there's plenty going on in this. So boats cannot leave if the height of the tide is greater than 2.65. So this is like a limit, safe limit to go, right? Okay. Shouldn't be above this. And due to the weather condition, there are some possible errors like 10 centimeters. So there are okay. So we are given the data in meters and this is a centimeter. So you do 10 divide 100, which is going to be a zero point 0.1. So plus minus zero point 0.1 is your error. There is some error going on. Robin wants to leave the harbor and go fishing as soon as possible after 12. So he goes after 12. Use the above information to determine the earliest time that it could be possible for Robin to leave the harbor. Give your answer to the nearest minute. Okay, so we need to do part D for this. This should be done using GDC, but let's take a look at this one. I need to sub in my function in the graph. Okay, let's go. So go to graph and minus 2.5 and put a cos. And this time you will write a 30x since b is found already, and 30x and plus a 4.5. So instead of h against t, I'm just using my GDC y against x, right? Okay, so here we go. Now it doesn't seem correct, so go to your viewing window and make your domain, let's say 0, that's fine, to 24. Okay, and you can check the y limits are also given. Mine is like way off. So let's go and check, make the minimum value 0 and the maximum value 8. And now let's see what do we get. And that's fine. That's a perfect graph, right? Okay, so now I'll just move on to the next part because I've got my function already inserted in the GDC. So let's take a look at this one. So I've got my graph. So use the above information to determine the earliest time that it could be possible for Robin to leave. So now keep in mind, like my limit is a 2.65, but I need the earliest possibility. So there is an error of 0.1. So do a 2.65 minus a 0.1, and that's going to be a 2.55. So instead of that, since you need the earliest possible time, go out and put a horizontal line of a 2.55. So keep in mind the earliest possibility. So let's go and go to GSolve and the intersect. And I need after 12. So this is the first time, which is a 13.291314. 13.291314. 13.29. Oh, this big answer. 131415. 131415. So now stop and think, like I need to give my answer to the nearest minute. Okay. So I need to change this rest of the part into, I'll show you how to do it. So first of all, you can subtract, forget about the 13. So that is the complete hour. So 0.291314 and 1.5. So this is like an hour version, but you can time it with 60, and that will give you a 17.4788. So this is like a 13 hours and 17 minute. So this is the time, right? I hope you get the idea. Like, what did I just do? Why did I subtract the error? Because I was trying to find the earliest possibility. There's some error going on. Okay. The boat will takes 15 minutes to travel from the harbor to the fishing site. Okay. So it takes 15 minutes. Robin intends to return to the harbor on the same day. He wants to be certain he will be able to get back into the harbor. Okay, fine. Part E, determine the maximum possible length of time he could spend at fishing site in hours and still be certain he will be able to enter the harbor on his return. Now, take a look at this. I'm just going to show you on the diagram what's going on. So he starts over here after 12, and there is some limit going on as well. So now he wants to spend like as much possible time. So the ending time should be as big as possible, as big as possible, because that's what's the error thing. And this should be as small as possible, right? So think about it this way. I need this the smallest possibility and this a biggest possibility. And don't forget, like, because it takes 15 minutes. So 15 minutes here and 15 minutes here. So that is another time. So keeping all that in mind, how do we check this? To get the max possible time and the minimum possible time. So I've got the lower limit already, which is like 13.29131415, and add uh 15 minutes and 15 minutes and like a half hour, so zero point 0.5. Add this and now I get the max possible time, which will be, just go back to your graph. Instead of a 2.55, now I'm going to change this to 2 point. What will be the upper limit? Okay, so if I add a 0.1, that's gonna be a 2.75. You know what did I just do? I'm doing 2.65 plus a 0.1 to get the greatest possibility. So it's like a sinusoidal function, but with a mix of the upper and lower bounds as well, right? So let's get G solve and go to the okay, G solve and okay, wait. What did I just do? I need to go to GSolve and intersect. Okay. So this is the max possible time, which is a 22.4809. 22.4809, and just subtract it, then that's going to be my answer. Okay, so this will be, let's go back. 22.4809, and subtract the sum of all these, 13.2913 and 1415, and add, remember, 15 minutes to go and 15 minutes to come back, so half an hour for that as well. And here we go. That's going to be 8.6896. 8.6896, which will approximately be 8.69, right? So nowhere does it say give your answer to the nearest minute or something. So that's it. Question 3, it's a 12-mark question. The diagram shows the cross section of a bridge and a river. A coordinate system has been added with the origin O. We can see that. At the point where the bridge meets the water on one side, all units are in meters. So we can see that there's a bridge and underneath there's a water. A coordinate system has been added. A researcher wants to calculate the volume of the water that flows under the bridge. To do this, he takes measurements of the depth every 1.9 meter from O. So it's like a 1.9 meters. So that is just like the step size, no? Okay. The depths are shown in the following table. Horizontal distance from O in meters, vertical distance of water in meters. All the information is there. Part A, use the trapezoidal rule to find the cross-sectional area of the river as it passes under the bridge. So if you are not familiar with the trapezoidal rule formula, it's given on the formula booklet. It's like half h and it's like y1 plus yn and rest of the or you can say y naught plus yn and rest of all the ordinates are double like y1 y2 and dot 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 yn minus 1. So I'm just writing the formula so that you know that it's given already. H is the step length which is given already 1.9, but I can give you the rule. It's like the upper limit and subtract the lower limit and divide it by the number of the uh, these rectangles, right? These trapezia, 1, 2, 3, 4. So it's 4, 4, and I can show you that it will end up 7.6. And if you divide it by 4, that's going to be a 1.9, right? So no need to do this, just refreshing what is a trapezium rule. So do a 1.9 divide 2, and I can see all the ordinates are already calculated. So I just need to put like this is a 0 and this is a 0 as well. So just double the middle ones. How many middle ones do I see? 1.68 plus a 2.81 and plus a 2.35, because these are the middle ones. They need to be doubled. And let's go plug this into a bracket. It's going to be 1.68 and plus 2.81 and plus it's going to be 2.32 and bracket close. Let's press it 13.62. Now you can divide this by 2 and you can multiply the answer with the 1.9, whatever way you want to do that. I'm just doing that 1.9. And this will give me a 12.939, 12.939, which is approximately 12.9. And this is the area of the cross section. Okay. The water flows under the bridge at the rate of zero point 0.3 meter per second. So the rate of water flowing is this, and the cross-sectional area is given. Now they're saying part B, find the volume of the water that passes under the bridge each second. So do take your answer from part A, 9.39, and time it with the 0.3, because we know that it's a cross-sectional area times the length. So every second, 0.3 meter of water passes, right? So keep that in mind, 0.3, and this is going to be 3.8817. 3.8817 is approximately 3.88. And this is like, since all the, uh, this must be meter cube per second, right? Or you can say meter cube second inverse. That's it. Let's go. A boat is traveling along the river. The cross section of the boat and the water level is shown in the following diagram. The top of the boat is parallel to the water level and has a width of 5. Okay, so this is the boat shown. The height of the boat is 2.35 meter above the water level, and the lowest part of the boat is 1.6 meter below the water level. So we can see it in the diagram. The boat is traveling down the center of the river. This is the water level, and this is shown over here, part C. Find the vertical distance between the lowest part of the boat and the bottom of the river as passes under the bridge. So in order to see the bottom of the river, we need to go back to the first diagram. So this is the lowest point. Oh, okay. So this is the lowest point, 2.81. So I can just use my answer, 2.81, and subtract. What are they saying? Find the vertical distance between the lowest part of the boat and the bottom of the river. So we know that this is a 1.6. So you can just subtract it and let's see what do we get. This is a 2.81 and subtract a 1.6. There we go. That's a 1.9. 0.21, right? Okay. The curved arch of the bridge can be modeled by the equation this. So curved arch is a quadratic function of the bridge. So we can see that the bridge is given like a curved arch. Look at this. It's given like a curved arch. So it's modeled as a quadratic function, 0 to 7.6. Part D. Find the maximum height of the curved arch above the water level. So now there are different ways. You can either use calculus or you can maybe just go to graph and graph it. And let's use a graph like we've already used a lot of calculus in the previous question. 0.15 x squared, both are acceptable ways. X squared and plus a 1.14 x and plus a 0.9. There we go. Let's set the domain as well, the view window, which is going to be 0 to a 7.6. And let's make the y window, let's say, because there are some negative values as well, like underneath. I'm going to put -3 to a 3. Or let's say maybe 5. I'm just setting it myself. So this is what it looks like, right? Go to GSolve and I can check the max, which is a so the maximum point is 3.8 and 3.066. 3.8 and 3.066. So they're saying the maximum height. So height should be 3.07, right? Meter. That's it. Okay. Determine whether the top of the boat will be able to pass through the bridge. Now, this is a good question. Like, how do you find whether the boat can pass through or not? In order to do so, we need to check it now. Like, let's go back in the diagram and we can check like, because the horizontal section is of the boat is 5 meter, right? So first of all, 7.6 minus a 5. Let's get this and see how much remaining part is there. So listen to this carefully. You can take out your GDCs as well and solve it with me. -5. Now it's a 2.6 divided by 2, right? So one of the part is 1.3, and if you do a 7.6 minus a 1.3, and that is going to be 6.3. So check what's 6.3. What does the function give as a height over here? And at 1.3, what is the height of this function? Because I need to check whether that since the height of the boat above the water level is at 2.35, if it exceeds 2.35, that's fine, my boat can pass through. If it is below 2.35, then the boat will not be able to pass from under the bridge. So 1.3 and 6.3, let's check these values. So minus 0.15 into a 1.3 and minus 0.15 into a 6.3. Square it plus a 1.14, 1.3 plus a 0.9 plus a 1.14 and a 6.3 and a 0.9. So if you know the quadratic functions, these values will look symmetrical because parabola gives you the symmetry, right? Oh, I need to delete. Let's delete all of this. And now minus a 0.15. Put a bracket over here and put a 1.3 bracket close, square it, plus a 1.14 bracket, 1.3, and plus a 0.9. Let's execute. And I'm getting a 2.1285 for this, 2.1285, which is below 2.35. So that is one complication. And you can just go back and verify in the same, like just go back and change these into a 6.3 instead, right? So it's already added there. I can just change it to 6.3 and let's go. And that's giving the same answer as well. So you will say that since this is your reason, because there's in determine, hence the boat will not be able to pass under the bridge, right? Question 4, it's a 16 mark question. The ferry routes between 5 ports A to E can be represented by a graph G. The adjacency matrix M for the graph G is shown below. Part A, state which direct route between ports can only be traveled in one direction. So we see A, B is 1, B and A is 1. So it's both ways. A, no connection between C and D. A to E is 1. Okay, and E to A is 0. So you can say A to E is 1 route, but E to A is a 0. So they are saying state which two direct routes between ports can only be traveled in one direction. So A and E. That's the first answer, right? Okay, part B. Find an appropriate matrix. By finding an appropriate matrix, part 1, show that it is not possible to reach all of the ports from any other port in exactly 3 trips. Now, this is an easy part, but you'll be needing to put in a matrix 5 by 5. And let's see, it is a bit hectic to do, but we can try. 1, 0, 1, 0, 1. And this will be a 0, 1, 0, 0, 0. And this is a 0, 0, 0, 0, 1. And a 0, 1, a 0, 1, and a 0. Okay. Let's raise it to power 3 since they are saying exactly 3. So what are we looking for? Okay, so you see there are some zeros over there. So they're saying by finding appropriate matrix. In your exam, you will be writing this on your answer sheet, but I'm not doing, I'm just writing the reason. So what's the reason? No, it is not possible because M cube has some zeros. Zero, you can say entries, right? Or whatever way you can choose different words as well, but that's the reason. Okay, part B2. State whether it is possible to reach all the ports from any other port in 3 trips or fewer. Justify your answer. So it's either 3 trips or 2 trips or 1 trip. Now we need to do the same thing. We need to add these and check whether it is possible. 0 entry is not allowed. So let's quickly add these matrices, right? 0, 1, 0, 0, 1. So if you are solving with me, you can take out your GDCs and do it as well. And if you're just watching, maybe you can skip this part, just move a bit forward and check the rest of the solution. 0 and 1. And this is going to be 0, 1, 0, 1, 0. And I'm going to raise this to power of 3. And now I need to add another matrix, which is the same thing, but with a square power, right? 3 or fewer. So 0, 1, 0, 0, 1. Oh boy, this part is really hectic. 0, 1, 0, 1. That's application course. And I mean, if you ask me, I really prefer the non-calculator math, but still there is a lot of learning in the application syllabus. And if you're using this technology, that's fine. 0, 1, and 0. And let's just square this. And one more to go. I need to add the simple matrix 5 by 5 as well, the same adjacency matrix. So 0, 1, 0, 0, 1, and I'm getting 1, 0, 1, 0, 1. and a 0, 1, a 0, 0, 0, and 0, 0, 0, 0, 1. Obviously, when you solve it on the actual exam, you will write these matrices over there. So let's go. And this time I do not have any zero entry. So you will say, yes, it's possible. And you can write since there are no zero entries. So it is possible for 3 or fewer trips, right? Okay, so let's move on to the next bit. And they're saying in the summer, there is a new timetable for ferry routes. The least cost in euros to travel between any two of the ports is shown in the table below. So these are the costs in euros. Part C. Given that there is no direct route between D and C or C and D, show that the value of A is 13 euro. In your answer, ensure you have considered all possible routes. So I can't go directly from D to C, which is this thing, or C to D, right? So that A, I need to show that it's 13 euros. So I mean, if I can't go directly from C to D, I can try some different routes, right? So I can move from, let's say, C to A and then A to D, right? Or maybe C to B and then to D. And or I can try C to E and E to D, right? So that's just like the concept of this question. So I need to consider all possibilities. So one of the possibility for part C can be CAD. And let's see, what does this give me? If I go from C to A first, that's a 7. And then from A to D with 8 and 7, that's a 15. Okay, so let's see the other ones. So if I move from C to B and then to D, so C to B is a 4, and then a B to D. Oh, that's a 9. Yes, that's a 13. So let's check what's CED now. So C to E, if I check my table, that's a 10. Okay. And then from E to D, that's a 3 as well. So you can see that like the least possibility is twice 13. Hence, 13 euros. EUR, right? So I've justified like at least like most common is a 13 euro. That's the cost. Okay, part D. So they're saying starting at A, use the nearest neighbor algorithm to find an upper bound for the cost of visiting all the ports and returning to your starting position. So remember, and if you have gone rusty, you can revise them again. What's the nearest neighbor algorithm? It's like you started a vertex, you move on to the next nearest vertex, and then you use the last vertex to reach back to the starting vertex. So in doing so, let's see, like, um, I mean, I usually don't encourage doing this question like this. It's better to make some sort of a diagram first, right? So A to B is a 3, okay? And then B to C is a 7. And then B to C. Oh, that's a 4. My bad. Sorry. B to C is a 4. I mean, it doesn't matter. You can make it roughly, but make sure you don't, because I usually sometimes get confused by my own graphs. Okay. And then from C to D. Oh, we just did that, right? That's a 13. So C to D is a 13. And then D to E is a 3. Okay. And let's check what is A to E. That's a 5. Okay. So this is one thing. Now I need to connect the inner graph. So A to C is a 7. Okay, let's write a tiny bit. And A to D is also given. A to D is 8. Okay, let's write it over here. And now I need to connect B to D. So B to D is going to be a 9. Let's write it over here. And B to E, this needs to be connected as well. That's a 6. Now A is connected with everything, B is connected with everything, C is not connected with E. Let's check what is the connect. Oh, that's a 10. Okay. And I think D is connected with everything as well. Now, we need to be careful in these kind of questions. So let's take a look at this carefully. So we start at A because they have given A. So the nearest possibility is B, right? So that is one possibility. And then the next closest possibility from B is C. Okay, let's go. And then we need to check where should we go from. If I go from C to D, that's a 13, but C to E looks cheaper. So let's go over here. So that is my graph. And then obviously not to the starting because I need to visit this vertex as well. That is E to D is 3. And finally, I need to go directly from D to A. So let's see what have we got now. So A to B is a 3 plus B to C is a 4. C to E is a 10 and D to E is a 3 and D to A is 8. Let's get this. This is like a 7, 17, 18, 19, 20, 28. So this is what I'm getting. All right, that's the upper bound. Nearest neighbor algorithm. Part E. By deleting the vertex A, use the deleted vertex algorithm to find the lower bound for the cost of visiting all pores. So again, you need to revise the deleted vertex algorithm as well. So what do? We delete vertex A. And by doing so, what will we be left with? So B will be there, C will be there, D will be there, and E will be there, right? So let's connect the graphs like they were. And all the branches that were uh, starting from A are disconnected now. But there is a branch between C and E and B and D. So where did A go and all its branches go? It's deleted. But in the end, you will use the two smallest branches which are coming out of A, add them, and that's going to be the lower bound. So that's like a graph theory chapter. Okay, so what do we do now? Uh, this is a 4, this is a 6, this is a 3, this is a 13, that's a 10, and that's a 9. So if I wish to visit all and I need a lower bound, so what should I do? I should start maybe here. Nowhere does it say where should I go. So these are the three vertices, 3, 6, and 4, right? So let's add 3 plus 6 plus 4. And now I need the smallest two branches, which were coming out of A. These were 3 and 5. So add them. 8, 4, 12. 12 and 6, 18. And finally, 18 and 3 is 21. So that's my lower bound. Question 5, it's a 15-mark question. The position of a particle P1 t seconds after leaving a point A is given by R equals to 210 plus t times a negative 447. This is a vector equation of line. So you know that this is the fixed point and that's the directional vector. All right, the units of the distance are meters. Part A, write down the coordinates of A. Since it's leaving the point A, so this is the initial position. So the position vector of OA is going to be 2, 1, 0. So just a 1 mark, they're asking for the coordinate. So you will write 2, 1, and 0. That should be your answer. 5 seconds after leaving A, P1 is at a point B. So after 5 seconds, the particle is at point B. So let's find OB's position first. That's going to be 210 plus 5 times negative 4, 4, and 7. So this is 2 minus a 20, negative 18. 1 plus 20, 21. And this is going to be, oh, my bad, 35. Okay. So I've got OB now. I've got OA. Let's get AB. How do we get it? OB minus OA. Vectors, uh, 35, and just subtract 210. And that's going to be -20, +20, and a 35. That is AB vector. So next part they're saying find the magnitude. So in order to find the magnitude, we can just sub in a -20 squared plus a 20 squared and plus a 35 squared, right? So let's use the calculator to get this. So square root 20 square and oh, that was negative, but you know it will turn out to be positive. You can, however, put it in your working plus a 35 and square. Let's execute, and that's 45. Okay, a second particle P2 leaves A at the same time as P1. P2 is moving in the direction of the vector this and passes through the point C. We're saying find CAB. So now here you need to understand that the position at any time of this particle P2 will be given because it leaves the point -1, 2, 0. Oh, sorry, my bad. It leaves the same point A, 2, 1, 0, and the directional vector is going to be -1, 2, and 0. So this is the general equation of the line, the vector equation of the line for this particle. And both passes through A. So you know that both passes through A, particle P1 and particle P2. So in order to find CAB, we can use the path vectors or the directional vectors. The directional vector for the first one is just a known scale diagram, is a -4, 4, and 7. And the directional vector for particle 2 is a -1, 2, 0. They are saying is moving in the direction with this. So in order to get this, I can just use scalar product, the dot product, right? So let's get the dot product of these vectors. How do we do that? -4, 4, 7. You can check the formula booklet. Dot -1, 2, 0. Divide the whole thing by the magnitude of this thing, which is going to be okay, 16 plus 16 plus 49 and root of 1 plus 4 plus 0. And that's a cos of CAB. Okay. So how do you do dot product? The formula is given. -4 times -1 is a 4 plus 8. And divide the whole thing by this thing. So I'm going to be using my calculator. 30. Let's get the square root. Shift square root 32 plus 49. Okay, and let's just multiply this as well. Save some time because that's going to be time. Another square root, which is just a square root 5. Okay, that's 9 root 5. So 12 divide the answer. I'm just putting it in my calculator. So I'm getting 4 root 5 over 15. So this whole thing will turn out to be 4 root 5 over 15. So just do the cosine inverse of this thing and you will get your answer. So let's do shift, a cos inverse, the answer. And I'm getting 53.3957. 53.3957. So they are saying give your answer. If no accuracy is given, you can give angles correct to 1 decimal place. There we go. Okay. The particle P2 has a speed of 12. Find the distance between P1 and P2. Okay, so the particle. All right, so this can be done very simply as well, again with cos rule. Look, particle P2 is traveling with a speed of 12, and at t is equal to 5, its distance is going to be 12 times 5, which is a 60. So you can think it this way, that from A, particle P2 is 60 meters away, and at the same time t is equal to 5, we just figured out that at t is equal to 5, particle P1 was 45 meters, right? 45 meters from A. So we've got the angle in the middle, which is a 53.3957. and we need the distance between them. So we can just use cost rule again, 60 squared, 45 squared minus 2, 60, 45, and cos of the answer angle is already given there, but you should write this the right thing, right? So this is distance between P1 and P2. So let's use our answer. I can do the cos answer again, and I can do into a negative 2 and times 60 and times a 45, bracket close. And in this, I'm going to add the 45 square and plus a 60 square, right? So that's this. And now we just square root the answer. And let's execute. And I'm getting 49.0414. 49.0414. Approximately, you can say 49.0. Question 6, it's a 15-mark question. Daphne runs a coffee shop and needs to decide whether she should hire more staff. Over a long period of time, the staff collect data on the number of customers C who are queuing when a new customer enters the shop. The probability distribution of C is shown in the following table. Okay, so this is a probability distribution, number of customers in the queue C 0, 1, 2, 3, more than equal to 4. So these are like in the line. The probabilities are given. Part A1, find the probability that there are at least 2 customers in the queue when a new customer arrives. So at least 2 means like 2 or more. So we can just use the probabilities. Or you can say probability customers more than equal to 2. Yeah, that's a better way to do it. 0.28, 0.17, and a 0. So we can just go to the GDC and do 0.28 and 0.17. Let's go. That's a 0.45. Okay. Part 2. Find the expected value, expectation. So we have a formula in the GDC. You can check that out. So it's number into probability. So we write 0 times a 0.21. I'm just doing the steps. I know the zeros customers, so that's the probability is this. Plus 1 customer, the probability is this. 2 customers, the probability is this. And 3 customers, the probability is this. And similarly for 4 or more, that's just a 0. Okay, let's ignore that. And I can just put, so it's just 0.34 plus 2 times 0.28 and plus 3 times a 0.17. Okay, so let's execute, and it's a 1.41. 1.41. Let's go. The time in seconds t taken to serve a single customer can be modeled by the normal distribution with a mean 115, and the variance is given 28 squared, so the standard deviation is 28. Okay, Daphne is told that an estimate for the expected time a customer will need to wait before being served can be found by calculating this probability, expected time for waiting and expected time for the customer, right, in the queue. So I've got my expectation, and for the expectation of this t distribution, the time in seconds, is just the mean, so 115. So expected value is the mean. So let's time this with 115. And I'm getting 162.15. So 162.15, or I mean, you can say 2 minutes is 120 seconds, 2 minute, and okay, 42.15, so 42 seconds roughly, right? But it's okay, fine. You can leave your answers as seconds. Nowhere does it restricts you to give your answer in that way, right? Okay, next part. Daphne now decides that she will employ a new member of the staff if the probability that a customer has to wait more than 3 minutes before being served is greater than 0.4. More than 3 minutes. Okay. So part C, using the distribution of T given above, find the probability that it takes more than 3 minutes to serve a randomly selected customer. So you got to be careful. I just read somewhere, yeah. So that was running in my head that this distribution is in seconds. So if they're saying more than 3 minutes, so you will write 3 more than 180. So 3 minutes is 180 seconds. So now I need to go to stats, distribution, normal, CD. For the lower, I need to put 180. And for the upper is fine. It's a huge number, 1 into 10 raised to power 50. I need to move to the standard deviation, which is a 28. And I need to plug in my mean, which is a 115. It's all set and done. Let's execute. And I'm getting a 0.01013. That's 0.01013. Let's write the whole thing. 186, but I can give my final answer as 0.0101, right? Okay. So let's move on to the next part. Find the probability that it takes more than 3 minutes in total to serve two randomly selected customers. So it's like T1 plus T2, right? So there are two customers now randomly selected. You may assume all serving times are independent of all other serving times. So now T2 will follow again, like for these two, you can form a linear combination that is part of the normal distribution HL course. So it's a normal distribution. So your mean is going to be doubled. So double of 115 is a 230, right? So, and it will be a double of the variance as well. So you need to check this out. So they're saying, find the probability that it takes more than 3 minutes in total to serve two randomly selected customers. So let's go back to exit it. And instead of the rest is fine, I need to change my variance. Let's put a double of 28 square just to be on the safer side. I'm just using this. And I think I should put a bracket so it doesn't mess up my work. And in place of the mean, I need to put, so you see the calculator already did that calculations for me. So 230. Let's execute. And this is giving me 0.8966, 4981. 0.8966, 4981, 4981. Oh, I'm running out of space because you know that like this is supposed to be done on the answer booklet, but I'm just using the question paper to solve it, right? Okay, next part. Daphne assumes that when a new customer arrives, the person at the front of the queue has only just reached the service counter. Okay, so when a new one arrives, the first one has only reached the counter. She also assumes that the probability that it takes more than 3 minutes to serve three customers is equal to 1. Okay, so more than 3 minutes for three customers is just 1. Part E, using Daphne's assumption and the probabilities for C, number of customers given in the table. Part 1, find the probability that probability a customer just arriving at the coffee shop will wait more than 3 minutes before being served. Okay, so we need the probabilities, but we need to use that data as well. So if no customer is in the queue, there is no waiting time, right? So that is just a 0. One customer, right? For one customer, we already found it for more than 3 minutes. That's a 0.01013,186. And for two customers, oh, I don't need to put a 2. I need to put a probability 0.28. So that's the probability of two customers. And we got it from the linear combination part. It's going to be 0.89664981. Okay. And for 3 customers, the probability was 0.17, and the serving time now I'm using is like a 0.89. Oh, sorry. 3 customers is just a one. I messed up. Okay, okay. Fine. So for 2 and 1, for everything is done. Let's get this. This was a bit tricky part, but you can always pause and read it again and try to connect with the question, because these paper 2 stats questions are, really theoretical sort. And if you are not fresh and not reading it carefully, anyone can mess up, right? So this plus 0.28 times 0. Let's just put the whole thing, 89664981. Oh, I need to put a bracket, okay? And plus a 0.17. Let's execute. And I'm getting a 0.4312. 0.4312. So my 3 significant answer is going to be this. Okay. The thing, hence state whether Daphne will decide to employ more staff. I think it's written. She was saying that if the probability of being served is greater than 0.4. So you will say that since for part 2, 0.431 is greater than 0.4, yes, she will hire new staff, right? And question 7, it's a 17 mark question. A fractal tree is shown on the following Argand diagram. So the x-axis is the real axis and y-axis is imaginary axis. So these fractals are definitely formed. I can see the angle given in radians. Okay, so let's see how this is formed. So they are saying the tree is formed in the following manner. The line segment joining 0 to 5 iota is rotated clockwise by pi over 12, about 0, which is the origin, to form the first branch, and then anti-clockwise by pi over 12, about 0, to form the second branch. The end of one of these branches is shown as A in diagram 1. All right, so the original complex number was 0 and 5. So 5 iota on the Argand diagram can be written like this. Part A, find the complex number represented by A, giving your answer in the exponential form. So we know when we rotate complex numbers, the modulus doesn't change. So the modulus is going to be 5. You can say R. Since I'm trying to write the R e iota theta, the exponential or the Euler form for the complex number. So the modulus is 5, and I need to find the argument. So argument is the angle with the positive real axis. So we need to calculate this thing. That's going to be pi over 2 minus a pi over 12. So this is times, I can do a 6. That's a 5 pi over 12, right? This angle is a 5 pi over 12. So argument is 5 pi over 12. So I can finally write it like 5 e iota, a 5 pi over 12. That's my answer for part A. Let's see what's the next one. Subsequent branches are created by adding 2 branches to the end of each branch created in the previous stage. Okay, we can see from each branch, 2 more form. Each new branch is 70% of the length of the previous one. Okay, so like this was a 5. This is a 5 as well. So we can check like what's going on. 5 into a 70%. So a 0.7. And that's going to be a 3.5. So each of these are like a 3.5, a 3.5, a 3.5, and a 3.5, right? Okay. One new branch is rotated pi over 12 clockwise for the direction of the previous branch, and the other is rotated anti-clockwise. This is shown in the diagram. So the previous branch, I mean, you can take a look at this. This is the same direction, but now it's rotated either way. Well, that's a unique kind of question. Okay. This process is continued using the end of all the branches formed in the previous stage as the center of rotation for the next stage. Okay, I need to just read this once again. This process is continued using the end of all the branches formed in the previous stage as the center of rotation for the next. Right, fine. So the previous ends are used at the center of rotation for the next ones. Okay, let's see. The trees after the third and the 10th stage are shown in the diagrams 3 and 4 respectively. Part B1. This is like the third stage and this is the 10th stage. Show that the total length of all the branches in the tree after the second stage, diagram 2, is equal to 24. Well, this is easy. This is 5. This is 5. I can see this is a 3.5. I just figured it out. 3.5, 3.5, and 3.5. So you can do, it's a double of a 5 and 4 times a 3.5. So this is a 10 plus a 14, and that's a 24. Okay. Part B2. Find the total length of all branches after 10 stages. Diagram 4. Oh boy. Now we need to figure out how to calculate this. Maybe we can form a sequence, like, because we know like it sort of forms a geometric system, the common ratio and the stuff, right? So it's a sequence going on. So first of all, we have a 2 and it's a 5 plus. Then it's I can do a 4, but let's say 2 squared and a 3.5, right? So now what just happened? I doubled it. 2 squared is a 4, right? Then it's going to be a 2 raised to power 3 because it's a 1, 2, 3, 4, 5, 6, 7, 8. And I can show you like what's going on. So if I do a 3.5 into a 0.7, that's going to be a 2.45 times a 2.45. And let's check one more just to show you that this does follow a geometric sequence. So if I do the answer into a 0.7, let's see what do we get. That's a 1.17, 1.715, 1.715. Okay, so this is definitely going to be a geometric sequence. So the first term is like a 10, and then 4 times 3.5 we already did. That's a 14. Plus 8 times, let's do 8 times a 2.45. That's a 19.6. So if you want to just verify, you can do 19.46 divide 14. And that's going to give you the common ratio 1.4. And similarly, a 14 divided 10 is also a 1.4. So you see? So you can say like we need to find the total length of all the branches. So let's say U1 is a 10, the common ratio is a 1.4. I need to find the sum of the 10, right? So U1 R raised to power 10 minus 1 over a 1.4 minus 1. In case you have forgotten, this is a sum of a geometric sequence, right? So let's do a 1.4 raised to power 10 and minus 1, time it with 10, and I need to divide it by, that's going to be a 0.4 in the denominator, right? So let's see. I'm getting 698.1366. 698.1366. So approximately you can say it's a 698, right? Okay. So part three, they're saying if this process continues indefinitely, state whether there is a limit to the total length of all branches. Remember, in a geometric sequence, this means that does the sum to infinity exist or not? So you will deny it since there is a restriction on sum infinity exists, just so you can take note, if R mod is less than 1. So you can say 1.4 is greater than 1, hence no limit. It will keep on increasing, right? Okay, next part. They're saying let B be the complex number represented by the point P in the diagram 3. Find an expression for B as a sum of three complex numbers, each written in the exponential form. So we need to calculate B now. So let's take a look at this. So first, it's like this is stage 1. So we know it already. It's a 5e iota 5 pi over 12, right? Plus, what will this be? So in order to check this, maybe we can move here. If we extend this and make an imaginary horizontal, if this is a 5 pi over 12, then this whole thing is a 5 pi over 12 as well. So subtract a pi over 12. Oh, so that's going to be a 4 pi over 12. And the length is reduced, 3.5. So I can write plus a 3.5 and e raised to power iota 4 pi over a 12. So I need to check it further what goes on next. So this is the case, or you can say that this is the scenario. So it goes over here. Let's make another horizontal over here. So this is a 4 pi over 12. So this thing is going to be a 4 pi over 12 and another pi over. Okay, so the last one is again going to be, which is a 2.45. So plus a 2.45 and e raised to power iota, again a 5 pi over 12. So you see, like, I mean, you can pause it and watch it all over again. Now they're saying, hence write down B in the form A plus IB. So how do you convert it? Now there's a nice trick you can use for this one. If you want to just write it, like go to Shift, Setup, and scroll down in your GDC. So you see my mode is right now real, but make it A plus IB. Now what will happen? Whatever I do, my final answer is going to be just A plus IB and I can find my. So let's type this in 5, Shift, E raised to power. So I'm getting 5 pi over a 12. And how to put an I, go to Option, Complex, and you'll see this I over there. So let's put an I over here. And plus, next is a 3.5. Again, the same thing, Shift. I'm writing the Euler form, which is a 4 pi over a 12. And remember the iota. Oh, another thing, very important. When you're putting the Euler form, make sure your calculator is set in radian mode, right? So I need to check that. Shift menu. Oh, mine is in degrees. This would have just messed up all this thing, right? So it has to be in radian if you are using the Euler form. And in any case, you know the angles are given in radian. So, sometimes you do mess up on such things. So the last one is 2.45. And let's put a shift e to the power. And again, it's a 5 pi over 12. And I. Okay, so now if I execute, I'll get straight away my answer. So I'm getting 3.678. Let's do it. 3.678 plus, what's the B value? Let's see. 10.227. So 10.227 I. So I can write it 3.68 plus 10.2 iota. And that's it for this exam. And if you have come this far, I I know that you are a serious candidate. Keep following for more useful resources. Over and out.